in between centers. Let us begin with the session.
Let us now look at the objectives of this session. At the end of this session, you will be able to prepare work for turning in between the centers. Set live and dead center proper alignment. Mount the catch plate. Set the bent tail carrier. Support the job in between center. The tools required to perform this operation are facing tool, center drill, drill chuck, driving plate, live center, dead center, lathe carrier, and surface gauge. Let us now learn to prepare the workpiece for turning in between centers. Turning workpiece in between centers avoids the need for truing the work. The workpiece needs the following preparation to be carried out before the actual operations are to be performed. Face both the ends of the workpiece. Perform the center drilling operation at both the ends. Dismantle the chuck from the spindle nose. Assemble the driving plate or catch plate. Assemble the spindle sleeve to the spindle nose. Fix the live center to the sleeve. Ensure that the spindle sleeve and live center are free from damages, burrs, and are thoroughly cleaned before assembly. Check for the true running of the live center with the help of a chalk. Select a suitable lathe carrier according to the diameter of the work and fasten it on one end of the work with the bent tail pointing outwards. Workpiece that has a finished surface should be protected by inserting a small sheet of copper or brass between the end of the screw and the workpiece in the carrier. Mount the dead center in tailstock spindle. Check live and dead center alignment. Apply grease to the center hole of the workpiece to be engaged by the tailstock dead center. Move the tailstock to a position on the bed to suit the length of the workpiece. The tailstock spindle should extend approximately 60 to 100 mm beyond tailstock. Clamp tailstock in position by tightening the tailstock clamp nut. Engage the work center hole with the point of live center and with the tail of the lathe carrier in the slot in the catch plate. Ensure that the tail of the lathe carrier does not rest on the bottom of the slot in the driving plate. Advance the tailstock spindle by the hand wheel rotation until the point of dead center enters the center hole of the work with proper seating, eliminating all endwise movement. Move the tail of the carrier back and forth while adjusting the hand wheel until only a slight resistance is left. Tighten the tailstock spindle clamp at this position and check that the resistance does not change. Set the machine for about 250 RPM and allow the work to run for a few seconds. Check once again for the resistance and adjust the tailstock spindle if needed. Work is now ready for operations. Before holding the work in between the centers, ensure that the centers are aligned. To recap, we have learned to prepare work for turning in between the centers. Set live and dead center proper alignment. Mount the catch plate. Set the bent tail carrier. Support the job in between center.
So that's all about the mounting job in between centers. See you in the next session. Hello and welcome to this session on making taper turning by form tool and compound slide swiveling. Let us begin with the session.
Let us now look at the objectives of this session. At the end of this session, you will be able to grind form tool for taper turning. Turn the taper using the form tool. Turn taper by compound slide swiveling method. Select drill size for taping. Drill blind hole to correct depth for tapping. Let us now understand taper turning operations. Taper turning involves gradually reducing the diameter of a cylindrical workpiece to create a conical or tapered shape. Taper turning operations can be performed by the following methods: forming tool, compound slide swiveling, taper turning attachment, tailstock offset method. The tools required for this operation are steel rule, outside calipers, facing tool, center drill, drill chuck, drill bits of various diameters, forming tools, M6 tap set, tap wrench, lubricating oil with can. Let us now learn the sequence for taper turning by form tool. Check the dimensions of the workpiece using steel rule and outside calipers. Hold the job such that 50 mm is projecting outside the chuck. Face the one end and make center drill. Drill 8 mm diameter through hole. Turn to 14.7 mm diameter to possible length. Turn to 12.2 mm diameter for a length of 41.5 mm from the faced end. Perform step turning to a diameter of 10.7 mm for a length of 12 mm, leaving 23 mm distance from the face to 35 mm. Perform an undercut to 10.7 mm diameter at 9 mm from the faced end. Perform step turning to a diameter of 11 mm for length of 9 mm from the faced end. Grind tool blanks to make special form tools to the degrees of 9 degrees 30 minutes and 6 degrees for taper turning operations. Set the 9 degrees 30 minutes performing tool perpendicular to the work axis to form taper by plunging. Set the machine to 1/3 of RPM for form turning. Feed the tool perpendicular to the axis of the work and form taper. Set the 6-degree form tool perpendicular to the work. Form the 6-degree taper. Remove the job, reverse and hold the work. Face the other end of the workpiece so as to maintain a total length of 50 mm. Perform turning operation to reduce the diameter to 12.2 mm for a length of 6 mm. Form radius R3 at the end. Deburr and complete work. Let us now learn the sequence for taper turning by compound slide swiveling. Check the dimensions of the workpiece using steel rule and outside calipers. Hold the job such that 35 mm is projecting outside the chuck. Hold the facing tool in the tool post and perform facing at the end. Perform center drilling operation. Perform drilling operation using 5 mm drill bit to a depth of 20 mm. Using M6 tap set and tap wrench, perform tapping operation on the job for 15 mm depth. Use cutting oil while tapping. Clear the chip by reversing the tap frequently. Remove the burrs on the tapped portion. Reverse and hold the job in the chuck by using soft packing pieces, aluminium, under the jaws. Face the job at the other end and maintain the total length of 68 mm. Swivel the top slide to half of the included angle 45 by 2, which is equal to 22.5 degrees of the taper away or towards the operator as required. Turn the taper by feeding the tool with the help of the top slide. Deburr the job and do final checking. To recap, we have learned to grind form tool for taper turning. Turn the taper using the form tool. Turn taper by compound slide swiveling method. Select drill size for tapping. Drill blind hole to correct depth for taping.
So that's all about making taper turning by form tool and compound slide swiveling. See you in the next session. Hello and welcome to this session on checking taper by bevel protractor and sine bar. Let us begin with the session.
Let us now look at the objectives of this session. At the end of this session, you will be able to identify the parts of a vernier bevel protractor. State the functions of each part. List the uses of a vernier bevel protractor. Check the angles of the machined parts up to an accuracy of plus or minus 5 minutes. State the working principle of a sine bar. The tools required for this operation are vernier bevel protractor, sine bar, dial gauge, slip gauges, surface table, single point cutting tool, lathe. Parts of a vernier bevel protractor. This is one of the contacting surfaces during the measurement of an angle. Preferably, it should stay connected with the surface from which the inclination is measured. The disc is an integrated part of the stock. It is circular in shape and the edge is graduated in degrees. It is pivoted to the disc and can be rotated through 360 degrees. The vernier scale of the instrument is attached to the dial. This is the other contacting surface of the instrument that contacts the work during measurement, preferably the inclined surfaces. Two kerned locking screws are provided, one to lock the dial to the disc and the other to lock the blade to the dial. Uses of a vernier bevel protractor. The vernier bevel protractor is used to measure acute angles, that is, less than 90 degrees. It is also used to measure the obtuse angles, that is, greater than 90 degrees. It is used for setting work-holding devices to angles on machine tools. It is used for setting work-holding devices to angles on work tables, etc. Let us now learn the sequence for checking the taper by using a bevel protractor. Mount the blank on the chuck and set the tool on the tool post. Perform taper turning operation for a length of 40 mm by compound slide swiveling method. Set the angular surface of the workpiece between the bevel protractor, blade and the face of the base. Lock the blade and the inner disc firmly with the locking device. Note the position of the vernier scale with reference to the main scale. Read the degrees of the main scale, MSR, at the graduation 0 of the vernier scale. Note the number of lines in the vernier scale that coincides CVSD with a division of the main scale. Total reading is equal to main scale reading plus coinciding vernier scale division multiplied by least count of 5 minutes. Let us now understand the working principle of the sine bar. A sine bar is a precision instrument meant for setting work to machine angular surfaces to determine the angles of tapered jobs by calculation. To check the correctness of a known angle, sine bar is used based on trigonometrical function of sine theta, where sine theta is equal to opposite side by hypotenuse. The hypotenuse is the length between the two rollers of the sine bar. The opposite side is the height of slip gauges. The height of the slip gauges is built up by using the formula sine theta equal to opposite side by hypotenuse. Let us now learn the sequence for checking the taper by using a sine bar and dial gauge. Mount the blank on the chuck and set the tool on the tool post. Perform the taper turning operation for a length of 40 mm by compound slide swiveling method for an angle of 30 degrees. Set the sine bar of 100 mm length on the surface plate. For an angle of 30 degree, sin 30 equal to opposite side divided by 100, which is equal to 50 mm. Mount the taper component on the sine bar after placing 50 mm slip gauge under one roller with the other roller resting on the datum surface. Mount the dial test indicator with a suitable stand. Set the dial test indicator at one end and ensure the dial is in 0 position. Move the dial indicator to the other end of the component. If the dial indicator reads 0 at both ends, the setting is OK. If there is any difference, then the angle set is incorrect. The height of the slip gauge must be adjusted till dial reads 0 at both ends. To recap, we have learned to identify the parts of a vernier bevel protractor. State the functions of each part. List the uses of a vernier bevel protractor. Check the angles of the machined parts up to an accuracy of plus or minus 5 minutes. State the working principle of a sine bar.
So that's all about checking taper by bevel protractor and sine bar. See you in the next session. Hello and welcome to this session on matching by Prussian blue. Let us begin with the session.
Let us now look at the objectives of the session. At the end of the session, you will be able to practice applying Persian blue, blue matching the male and female taper work pieces. Blue matching is used for checking the matching of the meeting surfaces. An extremely pigmented paste applied to serve in the mating of two elements is known as blue matching. In metal working, the marking out operation is done by the quick drying stain. Both the marking out blue and the scraping blue may also be referred to as engineer's blue. Engineer's blue is prepared by mixing Persian blue with an oily material, example, linseed oil. Tool makers widely use Persian blue when the concave and convex of a mold are matching during final assembly. Materials required to carry out this exercise are engineer's blue, male and female parts prepared in previous exercises which needs to be matched, microfiber cloth to clean the blue matching surfaces, brush to apply the engineer's blue. Let us now learn the sequence to blue matching of the given male and female taper parts. Examine both the male and female workpieces for any burrs, dirt, oil or grease. Clean both the male and female workpieces with any surfactant like diesel to remove the oil from the surface of the workpieces. Use a fine graded emery sheet to clear the burrs from the workpieces. Use a soft bristled brush to clear away the dirt from the workpieces. Wipe and clean both the male and female workpieces with a microfiber cloth. Apply couple of drops of Persian blue over the male workpiece. Spread it out evenly as a thin layer over the surface of the workpiece. Now gently insert the male workpiece, which is coated with the Persian blue, into the female workpiece. Slightly rotate the workpiece in one direction and avoid rotating in both directions. Now gently remove the male workpiece from the female workpiece. Notice if the Persian blue has rubbed over the entire curved surface of the female workpiece. To recap, we have learned to practice applying Persian blue, blue matching the male and female taper work pieces.
So that's all about matching by Persian blue. See you in the next session.
Hello viewers, welcome to DG Shala. I am Anuradha, Assistant Professor, National Institute of Rural Development, Panchayati Raj. Today we will be discussing about the UPI, Unified